Hello, Algebra 2. In 5.2 here, we're going to be multiplying and dividing rational expressions. Keep in mind what we're really doing here is factoring and simplifying over and over again. Here we go. The first thing to know is that when we say rational expression, we mean it's a quotient of two polynomials, meaning that something's being divided and it's an expression, so there's no equal sign, but there are going to be variables in either the numerator or the denominator or both. Here we go with simplifying. First one here, I'm just going to simplify 2 goes into 10 5 times, 2 goes into 6 3 times, and x to the 4th and x to the 8th will simplify, then this one will just become x to the 4th. Because remember, when you're dividing with exponents, you can subtract. So this would be x to the 8 minus 4 power, which is just x to the 4th. And so I end up with 5/3 times x to the 4th as my simplified expression. The directions here also tell us to find any values for x for which the expression is undefined. Because remember, we cannot divide by 0. So if I look back at my original expression, if x is 0, I would end up dividing by 0 here, which we cannot do. So I do have to say here that x cannot equal 0 because that's where it's going to be undefined. When I factor both the numerator and the denominator, this is what I end up with. And I can simplify and get rid of that x minus 1 because x minus 1 divided by x minus 1 is just the same thing as 1. And so what I'm left with is x plus 2 over x plus 3. Now to find where this one would be undefined, I'm going to look back up here to where I originally factored everything out. And I'm looking in the denominator, and I can see that if x is -3, then that denominator would be 0. So x cannot be -3 and x cannot be 1 because that would make this factor equal to 0. So if x is -3, the whole denominator would be 0. We cannot divide by 0. If x is 1, the whole denominator would be 0. We cannot divide by 0. So these are the values right here for which x is undefined. I want you to try factoring this one, the numerator and the denominator, on your own first. But before you do, there is a typo. This should be -6 on the end of that one. Here's what I end up with when I factor, and so I can get rid of the 3x plus 2 in the numerator and the denominator, and my simplified expression here would just be 2x plus 1 over 2x minus 3. I also need to figure out when this expression is undefined, so I'm looking at the denominator right here, and if 2x minus 3 equals 0, if this factor right here is 0, then the whole denominator would be 0. And if the other factor, 3x plus 2, was equal to 0, the whole denominator would be 0. So I need to solve these and figure out what values of x made that denominator 0. Here's what I end up with for both of them. And so x cannot equal 1/2 and x cannot equal -2/3. That's where the expression is undefined. When I factor this one, this is what I end up with. And I don't have any factors that I can eliminate right now, but I do notice that 4 minus x is really similar to x minus 4. So one little trick is if we factor out a -1, it can switch up those signs for us. So for example, up here, if I factor out a -1, that would give me -4 plus x as that first factor. Because if I take that -1 and I multiply it through again, then it gets back to this. And so then in the denominator, I still have x minus 4 times x plus 2. But I notice that right here, -4 plus x is the same thing as x minus 4. I can flip those around. So now these can simplify. And I'm left with -1x in the numerator over x plus 2 in the denominator. To figure out when this is undefined, I need to look in the denominator. X cannot equal 4, and x cannot equal -2. When I factor this one, I factored out a -2, and I was left with -5 plus x, which is the same thing as x minus 5. So I rewrote it. I can simplify right there, and so I'm just left with -2. That's it. But when is the expression undefined? Well, looking back up at the first part, x cannot equal 5. When we start multiplying rational expressions, it's really similar to multiplying fractions. Your book gives you these 4 steps. You're welcome to look back at those, but we're not necessarily going to use every step every time. We're going to start by multiplying these 2 expressions together. And what we're doing here is just simplifying, simplifying, simplifying. So I'm going to start by simplifying the number parts first. So 3 goes into 3 once, 3 goes into 9 3 times, 2 goes into 2 once, 2 goes into 10 5 times. Now I'm just going to simplify a couple variables as easily as I can. X to the third is going to simplify with this x to the third. And then I'm going to rewrite my function before it gets too messy. I still have x to the 5th times y to the 3rd times 5 times y to the 4th all over y to the 7th times 3 times x squared times y to the 5th. Now I'm going to keep on simplifying. My x squared would simplify with this x to the 5th and just make this x to the 3rd. Right here I have y to the 3rd and y to the 4th. Those together, you add the exponents, that's y to the 7th. So those would simplify with this y to the 7th. Now I'm just going to make note and circle of what I have left. X to the 3rd, 5, 3, and y to the 5th. So I write down what I have left with the numbers out front, 5x to the 3rd over 3y to the 5th. Once I have b factored, I can simplify some of these factors. The x plus 5 and the x minus 3 simplifies. So I'm just left with 1 over 4 times x plus 3. When we divide rational expressions, the biggest thing to remember is that dividing is the same as multiplying by the reciprocal. That's going to come in handy a lot here. So first thing I did with this division problem is I rewrote it as multiplying by the reciprocal. And now we can just do the same processes we've been doing, simplify everything that you can and until you get to your final answer. I tried to simplify everything in one step here. I kind of have a mess. So I'm going to circle what I have left. And then I'm going to rewrite everything. So I have x squared times y to the 3rd in the numerator, and in the denominator, all I have left is 3. When I simplified everything in this one, I ended up with just 3y over x squared. Here was my first step at factoring, but I can see a few pieces here that I can factor even more. Now it's fully factored, so I'm going to start simplifying. I can get rid of my x squared, the x minus 3 factor, the x plus 4 factor, and I'm just going to write out what I have left. This is what I'm left with. I can't factor it anymore, so I just stop right there. Now we have a few of these with equations. I have an equal sign in them, and we need to solve. The first step is going to be to factor, just like we've been doing. Once I've factored, I can simplify everything that I can, and I just write down what I have left, and then I just solve for x. And so I end up here with x to equal 9. I know from right here that x cannot equal 5. That's where the expression would be undefined, but that doesn't really matter here because I end up with an answer of x equals 9. If I did end up with an answer of x equals 5, but I know up here that x cannot equal 5, then there would be no solution. Before you start solving this one, there is a typo here. This should be a plus 3x. So when I solve this, I got rid of my x minus 2 factor. I end up with x plus 5 equals 7. So that means x equals 2. I always need to go back and check right here. X cannot equal 2 because that would make the function undefined. So this one has no solutions because I solved it. I got x to be 2, but in fact, x cannot equal 2.